Good morning, this is Dr. Turner for Integrated Math 1. Today we're going to be covering 9.3, which is looking at the triangle inequality theorem. We've covered this before in Math 8, and if you've taken the fundamental math class, it's also covered. But we're going to get into triangle inequality theorem and what are the repercussions of that. This is a fairly straightforward lesson, hopefully. If it's review, great. If it's a new assignment, also great. But let's go ahead and jump into it. So basically what the triangle inequality theorem states is that if I take the sum of any two sides of a triangle, then they have to be greater than the third side. So for any triangle, it doesn't matter what type it is, isosceles, equilateral, scalene, but for any triangle, call this ABC, the triangle inequality theorem itself states that if I add any two sides, so AB plus BC, that has to be greater than AC. Not greater than or equal to, it has to be greater. And BC plus AC has to be greater than AB. And AB plus AC has to be greater than BC. So any two sides, the sum has to be greater than the third side. So what this looks like for the first part of your assignment is I'll give you three measurements, and you're just asked, can these make a triangle? Why or why not? So for instance, let's say I have 3, 4, and 5. I could ask you, can these measurements, and I might give you units, I might not, but can these measurements form a triangle? So you would have to check. 3 plus 4, is that greater than 5? 4 plus 5, is that greater than 3? And 5 plus 4, is that greater than 3? Is 5 plus 3 greater than 4, rather. So you check all three combinations, and as long as it works, 1, 2, 3, then the answer is yes, these can form a right triangle. Depending on the question on the standardized test, and this comes up quite a bit on the CASP, if it's multiple choice, it might just be yes or no, right? If it's a free response, then it's yes or no and why. So if you have to justify your answer, then you would need to show your work. Now, it's important to note that when you're checking these, you have to check all three, right? If you just check one and then you make your determination, it's not enough. You have to show that all three pairs work out to be able to form the sides of a triangle. So, for instance, let's say I had something like 10, 7, and 2, right? Just as an example. So 10 plus 7, that's greater than 2, so I might just start out and say, okay, well, it works, therefore it's a triangle. Maybe I even do two problems, 10 plus 2. That's greater than 7, so that checks out. But 2 plus 7 is not greater than 10, right? So because it fails, that means no, these cannot form the sides of a triangle. So you have to check all three. Now, why is that? If you imagine, let's say you took out, a couple pieces of string. Let's say you had 10 centimeters for one, and you had 7 centimeters for the second, and you had 2 centimeters for the other. Even if you made a very, quote unquote, if you made a very flat triangle, right? If I were to take these sides, even if I lay them almost completely down, right? Even if I try to take those all the way down as flat as I possibly can, they're not going to connect, right? They're not going to connect, and therefore I can't make a triangle. So that's why the sum of any two have to be greater than the third. So that's the first part of this assignment. The second part is being able to determine, okay, well, if I give you two sides, and I know it's a triangle, then what are the possibilities for the third side? So let's take a different triangle. We'll still call it ABC, and why not? We'll put it upside down. Let's say I give you one side is 7 centimeters. Let's say the other is 6 centimeters. So the question is, what can this third side be? We're not going by the diagram. We're going by just the given information. So using the triangle inequality theorem, that means that the sum of any two has to be greater than the third. So if I add 7 and 6, it has to be greater than the third side, which is x. X plus 7 has to be greater than 6, and x plus 6 has to be greater than 7. So We are trying to establish a range of possible values for x. Now, the first, when we add the two numbers that are given, that's easy enough. 13 has to be greater than x. So that's half of our inequality. We're going to write it as a combined inequality. The other two, x plus 7 greater than 6, x plus 6 is greater than 7, these are a little bit redundant because one is going to cover the other. If I do x plus 7 greater than 6 in this specific example, that means x has to be greater than -1, but that's already implied because we're talking about a distance. We can't have a negative value for our triangle. However, if I do the second inequality, subtract 6 on both sides, x is greater than 1. So it's sort of implied that x has to be greater than -1, but x being greater than 1 would be the inequality that I'm focusing on. We're not focusing on both because they sort of cover each other, is the idea. Okay? So we're going to look at x being greater than 1. So 13 is greater than x is greater than 1. So I can write this as a single inequality where x has to be then, therefore, between 1 and 13. And that would be my answer as a combined inequality. X is somewhere between 1 and 13. Read as 1 is less than x, less is 13. So you will have a couple questions at the end of 9.3 that'll ask you to do that. Okay. The last thing we want to be able to do with this assignment, and I'll write here on the left because I have a little bit of space, is be able to show angles or sides in order. And so what this would look like is either I tell you what the smallest angle is and what the biggest angle is, or I could give you angle measurements. So let's say, again, not by diagram, A is 62 degrees, C is 58 degrees. I'm going to change this a little bit. A is, let's say, 72 degrees, C is 68 degrees, and B is 40 degrees, for instance. So as an extension of the inequality theorem, and we've covered this in fundamentals in 8th grade, but basically the smallest side is going to always be opposite the smallest angle. The smallest side is going to be opposite the smallest angle, and the longest side is going to be opposite the longest angle, and it would work the opposite direction. If I gave you the side lengths, then you could put the angles in order. So for a diagram like this, if I asked you to put the side lengths in order from shortest to longest, B is the smallest angle, so AC is the shortest side. And then the next largest angle is 68 degrees, so then AB would be the middle length size, and A is 72 degrees, so therefore BC would be the longest side. And it would be a similar process if I gave you the side lengths. So let's say, we'll call it ABC, and let's say A is 14 centimeters, AB is 15 centimeters, and B is 20 centimeters. I could also ask you, we'll put the angles in order. Shortest angle, or smallest angle, is opposite the shortest side. So from smallest to biggest then, it would go angle A, and then angle C, and then angle B. So shortest side, shortest angle, longest side, longest angle. That's it for today, guys. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.